find the average value of this thing here on this interval, what we really need to do is figure out the area. Let's just draw a sample function here. It may not be the exact same one as this one, but it gets the point across. So this one kind of looks something like this, just in some fashion. But we're going to go from 0 to 2. And what we're looking for is the average value. Now, the average value in here, right? If I were to find the area of this thing, and I were to find some average value, it would be where this area here fills in completely this area here, and it would be this, the average value would be right here on the function. So that's the idea, is we're trying to find where the area balances out and the whole thing. And so what that is the average value then would be this height. That's the average value that we want. Well, let me do it in a different color here. This rectangle has an area. Let's say it has an area A. Well, it's going to be this width here, which we know that's already 2. So the width of 2 times the height, which is the average we want to find. Well, if we want to find h, all we have to do is find the area and divide it by 2. Well, the area is going to be the exact same thing as the area under the original curve, because the area has to be the same. It's just the point at which the area evens out, but that's still going to be the same amount of area. So really all we have to figure out is what's the area underneath this curve on this interval, and that's just the integral from 0 to 2 of the function as defined. We can plug it into here, divide it by 2, and that gives us our average value of the height. So this one, of course, we can use a u substitution, x squared, then du equals 2x dx. That gives us du over 2 equals x dx, and x dx is right here. So that gets changed to du over 2. So we're going to get e to the power of x squared is just u. And we get du over 2. Of course, the over 2 can just move out in front. There's no need for that. So we get 1/2 eu du. And that's just going to be 1/2 eu evaluated at 0 and 2. Of course, we need to go back to the original function, which u is x squared. So this is going to be 1/2 e to the x squared evaluated at 0 and 2. And that's going to give us 1/2. Plug in 2, you get e to the 4. E to the 4. Plug in 0, we get e to the 0, which is just 1. So we're going to get minus 1. And this, of course, gets plugged into this. This is our area. So that's going to get plugged right into here. So we need to divide it by 2 again. So that's going to be 1/4 e to the 4 minus 1. That is our average value. That's our h value there. And that is A.